Okay, hello. Here's another question from your homework number 8. Um, this says, refer to the sample data for pre-employment drug screening shown below. If one of the subjects is randomly selected, what is the probability that the test result is a false positive? Who would suffer from a false positive result and why? Okay, so before we start trying to answer this question, let's just kind of dissect what this table is telling us. We can see here that these people are people who tested positive. We don't know whether or not they used the drugs. They're broken up. But if I add 38 plus 19, you're going to get 57 people tested positive. Okay. Over here, we have 31 plus 10. That is going to be 41 people tested negative. Okay. Then we have a second column or a second row over here of whether or not they're drug users. So we can see here from this line that we have 38 plus 10 or 48 people who use drugs and 19 plus 31, 50 people are not drug users. If I then figure out how many people altogether have been tested, were in this study, you can pick either column to add. You don't want to add them all because people will get double counted. But it looks like 48 plus 50 is 98 people were questioned in this study, were used in this study. Okay, so now the question becomes, what is the probability that the test result is a false positive? Well, we know that the probability of any event, in this case a false positive, is going to equal the number of ways you can get that, how many ways that can happen out of the total possible outcome. So what is a false positive? A false positive is somebody who tests positive but doesn't actually use the drugs. So if you sort of look here, if we break up this table, we can see this number here, 38, is people who use drugs and tested positive, which is probably the way it should be. Over here, down here at the 31, you have people who are not drug users and they tested negative, which is the way it should be. However, these two groups, some mistakes happened. For example, this top one, these subjects used drugs, but they had a negative result. It didn't show up. So maybe some of your athletes who get away with it. And then finally over here, these are the subjects who do not use drugs, but for some reason the test was positive. Who knows why? Maybe they took a legal substance that, some cold medicine or something, and it caused it to give a false positive. Nothing is ever 100%. So these are the numbers that we're actually looking for. These are the people that actually tested positive even though they are not drug users. So total ways you can get the outcome over total possible outcomes, which in this case is 98. This is always expressed as a decimal. I believe that's how they wanted it. So we'll do 19 divided by 98. You can just do that right on your calculator, and you will get 0.194 rounded to 3 decimal places. 0.194. Okay, that's how you're going to take a look. It's really taking the time to analyze your table before you tackle the problems. We could do another one, and for example, who tested, who had a false negative. Okay, well in that case, it would be the 10 people who tested negative, but in fact are drug users out of a possible 98 again. And that is a 0.102 result, so about 10%. Okay, up here you have about a 19% of people have false positives, and so you might want to be a little wary of your drug test. The question then goes on to ask, who would suffer from a false positive result? Well, who do you think? These are people who do not use drugs, but they're testing positive, so this is probably going to hurt the individual subject, individual employee, right? Because they may lose their job because they've tested positive for a drug that they're not using. How about the false negative? Who does that hurt? These are people who use drugs but tested negative. This might, in fact, hurt the company, because then they have employees that are drug users working at their company, which isn't always so good. All right. Thanks for watching.